Hello and welcome to the latest episode of the Last Week in AI podcast, where you can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am one of your hosts, Andrey. I finished my PhD at Stanford last year, and I now work at a generative AI startup.
And I'm your other host, Jeremy Harris, co-founder of Gladstone AI, an AI national security company, doing stuff with AI, WMD, loss of control, weaponization, all that good stuff. Andrey, when our last episode, we recorded on a Friday. We normally record these on Wednesdays. So I was like, hey, let's chat on Wednesday this time. And then Andrey rightly was like, let's just hold off for a couple days. We'll do it on Friday. It's been a slow news week. And we wait those 2 days, and then Llama 3 drops. And Microsoft says, hey, we can take a picture of your face and turn it into a video of you talking. So now that's cool. And we've got stuff from Intel. We've got stuff from Nvidia. It's just like, I don't know what it was, precognition, what you have going on there, but that was a good call.
I'm going to claim credit. That Llama 3, of course, is big news, probably the biggest news. So nice that we're going to be able to cover that this week. Hope people enjoyed the theme that Jeremy generated for last week. I did put that in. I think I might go back to the usual theme. I just kind of like it a little bit more, but maybe people had a kick out of that. Before we dig into the news, I just want to do a quick shout out to a new Apple podcast review we got from Cohere. Just says AI news and expert insights, apparently a must-listen podcast to stay informed about AI developments. I don't know if it's a must-listen, but we do hope we are able to let people stay informed. So thank you for that review, and as always, we do appreciate your feedback and comments.
Thanks so much, Jorge. Very much appreciate it.
And with that being said, let us just go ahead and dive into the news, starting with tools and apps. And the first story is Llama 3. So Meta has released Llama 3, the latest iteration of their openly released models. And for now, they released the 8 billion and 70 billion variants of the models. They are also training a 400 billion parameter model that it's kind of interesting. In the blog post, they say still training in parentheses, and they give some numbers, and those, I guess, are meant to compete with GPT-4. So these models are much better than Llama 2 by all the usual metrics. They are, let's say, around GPT 3.5-ish. They are beating out a lot of the other models at their same kind of punching weight, but still not, the GPT-4, best of the line models or, Claude 3, Opus, the biggest variant, still not quite there, but it's being trained, and I guess they are probably going to train it until it's as good or better is the aim. And with the announcement, they also went ahead and released it on all sorts of platforms. You can get the weights on Hugging Face. You can use it via cloud providers, etc. They say, I think it's already powering some aspects of Meta AI. So big news. Llama 3 is out. It's very good. And the range of weights people get to use as far as models that are open keep getting better and better.
Yeah, that's true. I think this has actually got a lot of implications strategically for other companies, and especially, we'll talk about this in a moment, but especially Anthropic. You talked about this idea that they're sort of teasing a model in training. We're seeing that as a trend more and more and more. Reka, we'll talk about that a little bit later today. Same story. They're in their case, they're actually kind of releasing feels like an early model checkpoint, really, or announcing an early model checkpoint that can already do stuff that you can already pay to access, I guess, or in some kind of private beta at least. So very much a theme. People want to let us know what's coming around the corner, possibly because, the benchmarks are constantly shifting, benchmark performance going up and up and up. And so you want to claim that victory while you can before the next model comes out. A couple of interesting details I thought about Llama 3 here. They talk about how it's trained on the models that is that they've just trained out and released now, the smaller ones, are trained using a data set that's 7 times larger than what was used for Llama 2, 4 times more code, which is interesting because when you think about it, that actually implies on a relative basis, they're actually doing less code per capita, less code per data point or per training sample, but still more code overall. So we should expect that coding performance to go up, and definitely, very steep increase in quantity of data, which is to be expected. You see that sort of naturally. It's 15 trillion tokens of data in that case. The hardware, interesting story here. So 2 clusters of about 24,000 Nvidia Tensor Core H100 GPUs. So going with the H100 is no surprise there. Pretty decently large, 24,000. That's a big size cluster for sure. And Meta definitely leaning into that heavily, right? They've advertised heavily. They're building up to 600,000 H100 equivalents by the end of the year. This is a big push for them to recruit, to get people to work for their research arm, because AI researchers, that's often the first question they ask when they're being recruited. How many H100s can I use? What is the availability to compute on this project? And this is a really big selling point there. So it's very important. They've got a lot of information, by the way, about their compute stack, the storage, the networking solutions, all this stuff. When you talk about pushing the limits on open source, and people have kind of talked about the deeper and deeper definitions of open source, not just releasing model weights, but also talking about the training process, releasing training checkpoints. Now we're getting into the compute stack and being open about what specific hardware and networking solutions you use. So that's certainly a thing here. 8,000 token context length, that's double what we see with Llama 2, at least the smaller models. So that's kind of interesting, not a huge bump. We're certainly not seeing those infinite context windows in the Llama series just yet, but yeah, I would say expect that to come around with the next beat for sure. And then one last thing I do want to highlight, actually two last things, one of which is really quick. The quick one is, this thing does not come with a generic open source license, of course, because we're talking about Meta. There has to be an asterisk, and the asterisk is it's open source as long as you don't have more than 700 million monthly active users in the preceding calendar month. In that case, you've got to request a license from Meta. So, Google, sorry, other companies that, Netflix and so on, other companies that operate at scale, maybe don't go using Llama 3, no surprise there. They've done that before. Very clear who they're carving out there, but it's a mostly open source model. Last thing I wanted to call out here, and this is that strategic point I mentioned out the gate, you think about a company like Anthropic, right, that's very safety oriented and that had a policy until quite recently of explicitly not releasing field defining models. Claude 3 Opus may have been, depending on how you think about it, may have been a break in that policy where they are sort of outperforming the GPT-4 Turbo in some respects. At the time it was released, it certainly was, for some metrics, the leading model. But Anthropic's fast following strategy here is because they don't want to exacerbate racing dynamics. They see that as one of the biggest drivers of risk at the frontier of development. But now that we're looking at Meta basically open sourcing a model which, it looks like the 400 billion parameter version of Llama 3 will be competitive with Claude 3 Opus and Gemini 4, and GPT-4 Turbo. That means that open source frontier is really creeping up pretty fast. Again, it doesn't mean when a model is open source, especially a 400 billion parameter model, that doesn't mean it's available really for free, right? The cost of inference is still really high. You need a lot of hardware to fit a 400 billion parameter model, but it definitely means that now, you're sort of competing on inference costs. You're trying to come up with, you're only competing on, is it easier and cheaper to go with like a pre-made solution that's already deployed where you just ping an API versus setting everything up yourself. And that drives down your margins quite considerably. So I think this is a strategic question for Anthropic now. You've got OpenAI pushing ahead very fast. Anthropic wants to fast follow. They don't want to push OpenAI even faster. But creeping up behind them is this rolling barrage of open source models with Meta at the lead and really kind of chipping away at the heels of the GPT-4 class of models. Anthropic won't really have had a big window for Claude 3 Opus to be the only game in town before you see Meta's release. So I think this is just really interesting strategically. What does that do to the kind of the racing dynamics around here? What does that do to the margin of companies that build proprietary sort of frontier models? Really interesting question. And we're just going to have to see that play out over the coming months and years.
some interesting points, and I'll throw in just a couple more things before we move on. In the GitHub model card, there's a lot of details. One fun detail is for the 70 billion variation of a model, they actually specify the power consumption, and they say that it took 6.4 million GPU hours to train that 70 million parameter model. And then they kind of, from that, estimate the carbon emitted and say that it was all offset. So I found that kind of interesting just to get a sense of the scale of these training runs, right? That's why they cost millions of dollars. It's really incredible that we now have a lot of people training these gigantic things. One more detail also is now this has an 8K context length. So this is doubling the amount of input you can give it compared to Llama 2. And that's still relatively small compared to the things you can get with Anthropic and GPT. So in some sense, that could be one disadvantage of this if you're thinking of as far as comparisons go. So yeah, some notable improvements, and impressive that Meta is throwing a lot of money at continuing to be, trying to be the best open source LLM, although, they compare to Mistral and Gemma in these benchmarks, which were better prior to this, to Llama 2. So a real kind of competition going on as far as, especially for that 7 billion parameter spot, as far as models being released all the time, but also now for that 70 billion parameter spot.
Yeah, I would say, when we look at the context window piece, I would expect that context window to be dramatically larger for the, the 400 billion parameter version of the model when it comes out. Just because context window size generally does correlate with the size of the model itself for various reasons. One thing, though, that is worth noting, actually, last quick thought at my end, because this is strategic, it does speak to our sort of understanding of where AI training runs are going, big picture. One thing we've seen a lot, especially lately, is people breaking down that sort of the famous Chinchilla Scaling law paper. Folks might remember. I'm not sure if we covered it at the time. It might have been shortly before we started co-hosting this together. But back in the day of like just pre-GPT-3, OpenAI came up with a series of scaling laws. Basically, these are laws that tell you, well, if this is the amount of processing power, this is the amount of computing power you're going to throw at your model, this is the size of your data set, here is the optimal size of the model you should be training, basically. And then later, Google DeepMind came out and said, hey, well, wait a minute, you guys have made a mistake. Essentially, you're undercounting the importance of the training data dimension of this. You should actually be training with more training data on your models. And they showed through fairly interesting analysis that we'll talk about actually later today with another paper that kind of broke that down, just how you could do it more optimally, training these so-called compute optimal models. Now, a compute optimal model is often the way this is done. People will take their model and they'll figure out, okay, my compute budget is this. I can spend $10 million training this thing. So automatically, these scaling laws tell you how much data you should be training it on and what the size of your model ought to be. What is happening here, though, is Llama 3 is being overtrained. It's being trained past the point of compute optimality. And that's something you'll often want to do, especially with smaller models, because you want them to perform better. They will keep performing better if you pour more computing power into them. It's just that if you made the model bigger, it could make better use of that computing power that you're pouring in. But in this case, if your model size is the constraint, you're making an $8 billion model, 8 billion parameter model, you want that thing to be able to fit on a small device. Then overtraining it can make sense. So both these things have been heavily overtrained. They said that they found that model performance continues to improve even after the model is trained on 2 orders of magnitude more data than the standard sort of Chinchilla optimal amount of training compute. So that's, I thought, really interesting and an indication of sort of where things are going. More and more, we're seeing the models get overtrained, especially the smaller ones.
And on to the next story. Speaking of previews of upcoming models, as you mentioned, Jeremy, the next story is Grok-1.5 Vision, which was just unveiled by XAI and not released yet. It will be soon available to testers and existing Grok users, but we did get the announcement and some details. And the big deal is the vision part, right? Grok so far has been just a language model, and now they are adding that vision component. On benchmarks, it seems to be about, again, something like GPT 3.5 or Claude 3 Sonnet, not quite at the GPT-4 level on most benchmarks, although there are a few where it does do equivalently-ish. So yeah, that's pretty much the story. We don't have too many details compared to that Llama 3 release. Not a ton of specifics to get into, but it's certainly notable that XAI is continuing to push on training Grok and I guess trying to compete by adding that vision component that GPT-4 and Claude also have.
Yeah, and there's one metric here, a couple metrics that I thought were especially interesting to tease out here. Especially, XAI has kind of come out of nowhere, right? I mean, they had Grok. Grok has been okay so far, but this is the first time we've seen a model that comes anywhere close to like defining the frontier in some dimensions. So there's this Math Vista benchmark where it actually beats Claude 3 Opus, which is frankly astonishing. Again, another instance of this pressure on Anthropic and their general strategy, and I have immense sympathy for them. I think they're trying to figure out how to do this without exacerbating the racing dynamics, and it's a really hard thing to do. But this fast following thing it gets trickier as things get opened up at that level. When you look at the Math Vista benchmark, though, it's quite interesting. It came out about 6 months ago. So it could have been in Grok 1.5's training data in some form and not in Claude 3 Opus's, depending on the timing of when Claude 3's dataset collection process started and ended and Grok 1.5's. So this is always something you want to look at anytime there's a really surprising benchmark. It's like, okay, is there a possibility of some data leakage here? That's, I was scratching my head about that. I looked into the timing of this as much as I could. It's a bit ambiguous, but what's not ambiguous is that Grok 1.5e does outperform its competitors on this real world QA data set or benchmark. And this is a new metric that they created to evaluate real world spatial understanding. So it is absolutely new. There's no risk of leakage here ostensibly. It's got more than 700 images along with question and answer for each of them. And in any case, this is a data set also that XAI is going to be releasing under a Creative Commons license, but it does smash like even GPT-4V hitting almost 69% to GPT-4's 61.4%. So it's a pretty dramatic improvement, again, on a fresh and clean benchmark. So that's definitely something to watch.
As always, we do want to mention like caveat benchmarks are, let's say, not perfect, and depending on how this was trained, there might have been leakage, not on that new one, as you said. Presumably, they did not train on their own data, although they may have collected some extra training data, for the training set, and then evaluated on the test set on this real-world QA benchmark. So, we don't know too many details. Do take the numbers with a grain of salt, but regardless, pretty big news that XAI is competing now in the language plus vision front. And moving on to lightning round, a few more stories, and continuing on our roll of new model announcements. The next one is Reka Core, which is another multimodal language model to rival, in this case, GPT-4 and Claude 3 Opus. So Reka is a San Francisco-based startup with a lot of talent from DeepMind, Google, and Meta. Now they have allowed or released this model to their API and various deployment options. This is the third of their models. And yeah, they say that it beats Claude 3 Opus, beats Gemini Pro 1.0, not quite at the GPT-4 level. And that's according to human evaluations, apparently. So another pretty performant model. This is coming from a 22-person company, interestingly. So it's, pretty crazy how many, I guess, players are in this space of training models and competing for people's money, as far as where you deploy on which model.
Yeah, well, I mean, Peter Thiel once said famously, competition is for losers, right? And he was referring to kind of what happens, when you enter this territory. Though, like, you have to have by far and away the best model in order to be able to charge margin on it. And this is, another competitor at that level. I will note 128,000 token context window. And Reka here recognizes explicitly that it can support agentic workflows. Those two things are, of course, not unrelated. If you want to do good agentic workflows, you do need a large enough context window to support that. And so this is, in some sense, like Reka very much carving out this space. They want to make sure their models can satisfy that need. So kind of interesting. They are releasing two smaller models along with their kind of big one, which is Core. It has, it's very multimodal. I think you might have said this, but images, videos, and audio. As they put it, it's one of only two commercially available comprehensive multimodal solutions. Again, the language here is doing a lot of the heavy lifting. You've got a lot of models right now that are multimodal or increasingly so, depending on how you want to think about comprehensive. Yeah, sure. But certainly is an impressive development, especially, as you said, Andrey, from such a small team. One other thing to note, it's available via an API. They also offer it on-prem, so on-premises. If you've got a company, you got your own servers, you don't want to be sending your data to OpenAI, their pitch is, we will essentially allow you to run this on-premises so that privacy is less of an issue. This is kind of more in the Cohere direction. We've seen them, of course, a big OpenAI competitor, run the same play, try to build systems that are designed to go on-premises and help enterprises with that problem. I thought that was really interesting. They also offer on-device as well, as they put it, to satisfy the deployment constraints of our customers and partners. So very much something you would expect to see more for like an enterprise play, or potentially more compatible as well with a defense or national security oriented application where you have to be able to get the authority to operate, and maybe that requires actually running this thing on secure servers that are kind of carved out. So really interesting. A bunch of impressive benchmarks. They've got Edge, Flash, and Core. Edge being the smaller one, 7 billion parameter model. 21 billion parameter dense model called Flash is also out. Both of those are trained on roughly 5 trillion text tokens. And Core is the big one, of course, 128,000 token context window. We don't know what the model size is. We don't know what the number of text tokens are because it is still in training. So that, again, an indication of a company building a system that they want to pre-release, essentially. Let us know, hey, we've done these impressive things, but it's still a work in progress.
Next up, one more announcement of a new model, and then we'll be moving on. This one from Cohere, which we've been mentioning quite a few. The announcement is of a private beta for Cohere Compass, which is a bit different from the other ones. This is a foundation embedding model that allows indexing and searching on multi-aspect data. So for instance, they say that in enterprise data, you have emails, invoices, CVs, support tickets, log messages, tabular data, all sorts of data that isn't images or text or audio exactly. And so this model kind of takes in all of those kinds of things and lets you embed it and therefore search for relevant or related documents. And yeah, very distinct from the other types of models we've seen. Cohere seems to be really, optimizing for embedding and search as one of the applications they provide to businesses. And what I've seen is Command R, their embedding models have gotten a pretty strong reputation. So this presumably is a pretty strong play by them for companies that do have needs in this kind of very specific various types of data.
Yeah, and so consistent, as you said, too, with their enterprise focus, right? I mean, this is really about the kind of data that you run into there: emails, invoices, CVs, support tickets, log messages, tabular data, right? That's really what you want to be able to work with. And of course, Cohere has made that their differentiator from day one, right? OpenAI came out and they said, hey, basically we're B2C, we're business to consumer. That was at least the initial release. And then Cohere was like, okay, well, we're going to take the enterprise then and try to do on-premises, try to do, these kinds of models. So very consistent with that overall approach.
Next up, we have a story related to something that anyone could use, not businesses. The story is Amazon Music's Maestro lets listeners make AI playlists. So in case you don't know, Amazon has a music app that competes with Spotify and all the other ones. And they are now testing Maestro, which is an AI playlist maker, apparently so far with a small number of subscribers in the US. So you would be able to create a playlist from text prompts essentially here. And this is, of course, similar to Spotify's AI playlist, which was recently launched for premium users in the UK and Australia. So yeah, competition heating up in the music streaming space for integrating AI. And just one more story is that Snap plans to add watermarks to images created with its AI-powered tools. Snap, the social media service, has these features where you can create images just like you can in Meta tools and GPT and so on. Apparently, they will be adding a translucent version of the Snap logo with a sparkle emoji to indicate that it was generated with AI, similar to what you have with some of the other image generation tools out there also now. So yeah, that's pretty much the story. Kind of interesting to see that this is becoming more and more of a norm to have watermarks on AI-generated images.
Yeah, it snaps under a little bit of pressure to kind of roll things out in this direction. They had some controversy famously over their My AI chatbot, which apparently led to rolling out controls in the family center for parents and guardians to monitor and restrict their kids' interactions with AI. Basically, issues came up with the sort of like chatbot interactions, as you might imagine with children. It's a high stakes application, obviously. So maybe trying to invest a little bit more into the security and safety side, and this does seem like one of those common sense measures.
And moving on to applications and business, and the first story is that Boston Dynamics has a new humanoid robot out. So, of course, Boston Dynamics is famous for having their dog robots and having their really big humanoid robots that can do parkour. Well, this one is pretty different from that. It's all electric, so not using hydraulic actuation anymore. And it is a little bit leaner and smaller and has, you can watch the video really to get a sense for it, but it's
pretty wild.
Pretty wild. Yeah, it has the ability to rotate its torso and its head, fully around. And I guess the aim here is to actually commercialize this. So compared to Atlas, which was always more or less just R&D previously, this new electric Atlas is said to be stronger and has a broader range of motions than previous generations. Boston Dynamics is already commercializing to some extent its quadruped robots, the dogs. It is being deployed in some industrial applications and some police applications. So I guess they're now in the race to have humanoids deployed out in the field, and we've covered it quite a bit with companies like Figure and others building also humanoid robots. Now Boston Dynamics is in that race.
Yeah, we really got a good sense of where they're going long term with this along a couple of different dimensions that I didn't expect to learn about here. Yeah, the first was just this philosophy that the human form factor is good as far as it goes. You definitely want these robots to be able to do anything a human can do, roughly speaking, like physically. But that doesn't preclude giving them additional capabilities, like, as you said, Andrey, the ability to just like rotate their frame around instead of having to like awkwardly. If you think about how a human turns around, right? You kind of like awkwardly move maybe your right foot first and a little bit faster, and then your left foot catches up behind or whatever. You waddle to rotate. Well, this robot just like rotates its upper body and then kind of starts walking the other direction, which over the course of repeated motions, right, on a factory floor or whatever you're talking about, could lead to significant time savings. But definitely, you're starting to see that some of the advantages of the robotic form factor over even the human form factor, like human design is not necessarily the end of the road. And they've made that very clear in their design philosophy here. They are looking at this interesting design too, that has the sort of head is like this, I don't know, it looks like a makeup mirror with like, it's a circular mirror almost looking thing with a light, a circular light at the top. It's worth looking up. It's kind of fairly striking. And a lot of range of motion. It's a very distinct robot with clearly impressive, at least demo capabilities. One of the things that they highlighted too was they're not, unlike a lot of other companies, and when we've covered some of these, right? We've talked about, well, we're not sure if Optimus will do this, but likely will or could. Figure One though, and so on, that are building platforms. Right. The idea is to make a robot that can, other people can code for it, sort of have like an app store for your robotic system so that people can build it out. They seem to be more focused on specific applications, focusing down specific applications and use cases out the gate and not building a platform first. And that definitely is a distinguishing feature. as they say in this quote, our experience is that the way to go fast is to focus on an application and go solve problems and not assume someone else is going to do it for us. So sort of, anyway, I thought a pretty interesting piece of differentiation. Finally, they do call out that they've had a bunch of interest in Boston Dynamics in this kind of general design direction, and that it was motivated by a couple of different factors. One key one has been the development of general purpose AI capabilities that can help solve for some of the weird edge cases that robotic systems actually run into when they interact with the real world. And so this idea of these general purpose language models as an accelerant for robotic systems, we've been talking about that for a long time. Obviously, it's been clear things are headed this way, but they explicitly make a point of saying, this is one of the key enablers of this generation of technology. So yeah, pretty interesting. And they do highlight that, by the way, Tesla expressing interest in manufacturing sort of validated a lot of the things they've been doing for a long time. And certainly the idea of Optimus potentially coming on the market at some point will be an additional motivator to move fast and build things.
Next up, as usual, we got to talk about some hardware-related stories, and not hardware in terms of robotics, but hardware in terms of chips. And the story is TSMC's 65 billion bet still leaves US missing piece of chip puzzle. This is, I guess, more of an analysis piece from Ars Technica. So there is a 65 billion planned investments in Arizona from TSMC, the biggest chip fabricator in the world. And this article claims that with regards to AI chips, potentially those will still not be being built in the US just due to the complexity involved in packages. So they will still likely be involving at least plants in Asia and not be all US. But this is a good kind of overview of TSMC's commitment in general. They are also committed to having a third plant using the super advanced 2 nanometer technology by 2030. They are planning to build 3 nanometer chips in 2028 in the US. So lots of plans here for TSMCs to expand. And that's a lot, of course, with a lot of support from the US government and the Chips and Science Act.
Yeah, this is actually, I thought, just a really good scene-setting piece with some new insights. So yeah, specifically, back in the day, so the Chips and Science Act passed, and there was this commitment of the US government to give about $5 billion in loans and $6.6 billion in grants to TSMC to have them set up these plants on US soil. That, of course, is a national security imperative. You can't have all of the most advanced semiconductor nodes in the world being fabricated on Taiwan, which is right next to an adversary state. So at the time, the idea was for TSMC by 2026 or so to be working at in their US domiciled fabs, to be working on their 3 nanometer process, to have a 3 nanometer process underway in the US. That's what TSMC had previously committed to. Now, if you'll recall, 3 nanometer process is the current leading edge node in Taiwan today. That is the process that's giving us the iPhone, right? So essentially what tends to happen is the iPhone and smartphones tend to dominate that smallest process, the most advanced process. And then you have the kind of laggard nodes, so the 5 nanometer node, next level up, which tends to be used for AI applications. And so what happens is as the iPhone, as Apple basically subsidizes the innovation that goes into the next node, so after this, the 2 nanometer node, that frees up the 3 nanometer node for AI applications and other advanced widgets, let's say. What we're learning here is that essentially TSMC is accelerating their timeline for reaching not 3 nanometer, but 2 nanometer production in the United States by 2026. That would be fairly significant. It means that we can start to produce not H100 equivalents or even B100 equivalents, because those are still running on the 3 nanometer process, but whatever the next generation is going to be by 2026 on US soil. Okay, that's the theory. The problem, as you highlighted, is that just the fabrication of a 2 nanometer node on US soil is not enough to get you a cutting edge GPU. Because in addition to making these crazy accurate, small, tiny 2 nanometer chips, you also have to package them together using advanced packaging technology. You also have to use high bandwidth memory. chips that basically are made by typically SK Hynix, which is a South Korean company, and you need components from Samsung, which are still not going to be manufactured on US soil. So unfortunately, from the standpoint of the whole supply chain that you need to actually make these GPUs domestically, we are not there yet, but we will by at least 2028 is the hypothesis here. Sorry, I should have said 2028, by the way. I said 2026. That's when Nvidia is going to start using 2 nanometers globally. But in the US, by 2028, you're only going to have, presumably, the 2 nanometer chipsets being fabricated here, not the packaging, not the high bandwidth memory. So parts of the supply chain are being onshored, but it's not the whole thing. So I thought that was quite interesting. Another piece that's highlighted in this article, I think quite accurately and interestingly, is any access to a specific plant. If you're a company like Nvidia and you want access to a particular plant that's fabricating in a particular jurisdiction, you're going to have a separate agreement with those customers, and possibly in exchange for a price premium, right? Like, you want the chips that are fabbed in this location. Okay, well then that's going to come at a cost. You don't get your chips from just anywhere. If you want to choose the location of the fab that makes your chips for national security reasons or cost of delivery, then that's a sort of an additional cost. So this kind of ends up giving TSMC another degree of freedom on pricing, and the market generally another degree of freedom on pricing. Who knows where that'll settle? But it's also worth noting TSMC faces some risk here, because if they do move too fast, if they start to expand too quickly, the big risk they face is that the fabs they build will have crappy yields, and that is TSMC's big differentiator. It's the reason they have such high margins. They're able to pump out these 3 nanometer, 5 nanometer chipsets or chips at very, very high yields, i.e., a large fraction of the chips they make are actually useful. And that's where margin comes from. That's where profit comes from. So if they move too fast, that can take a ding, and that affects profitability in the whole business model, basically. So I thought fascinating overview. If you're interested in the hardware piece, the CHIPS Act, the onshoring, definitely check this out. It's worth a read.
On to the lightning round, and one more story related to chips, but this time related to policy. The story is that the US blacklists Intel's and Nvidia's key partner China, and 3 other Chinese firms also included in blacklists for helping the military. Long title that summarizes a lot of it. So the US Department of Commerce's Bureau of Industry and Security has added the Chinese solutions provider Seaton Holy to its entity list, which apparently affects its partnerships with American companies that work with them. The company will need to try and obtain an export license from the US government, which will presumably be met with denial. There are also 4 other Chinese companies that have been added to the US export blacklist for apparently their involvement in acquiring AI chips for China's military. So, pretty clear reminder that there's very much an ongoing effort by the US government to restrict China's access to chips and generally keep a tight lid on exports.
Yeah, one question that's always raised in this context too is like, how general do the export controls have to be effective, and how meaningful is it to identify individual companies and say, okay, well, you can't export to them, but then Intel, Nvidia, and so on can still export to other companies in China, and so if Seaton Holy doesn't buy, then others may as well, and the black market is pretty black over there, and so yeah, I mean, I think it'll be interesting to see if this whole entity list strategy ends up working, or if a whitelisting strategy ends up taking hold in the long term. No idea. It seems like a generally fairly leaky strategy potentially, and we're seeing that play out as they play this game of whack-a-mole, identifying new companies that seem to be violating in the spirit of the law here. So
next up, Elon Musk says the next generation Grok-3 model will require 100,000 Nvidia H100 GPUs to train. That's pretty much the story. Apparently, there have already been 20,000 Nvidia H100 GPUs used, according to Elon Musk. And yeah, next up, it's going to be 100,000 just to indicate the scale of these training runs.
Yeah, and he's coming out and saying that the next version of Grok is expected to complete its next training phase by May. So Yeah, we'll, I guess, have another friggin' Grok model by May. So there you go. Happy May. One of the interesting things, by the way, that they do highlight here, 100,000 GPUs for that kind of training run, and anyway, associated workloads could consume about 70 megawatts of power, or 100 megawatts when you factor in the kind of cooling infrastructure that you need as well. Which, when you actually like math it out, it is the amount of power consumed by New York City in 1 week. Right. So we're really talking about large power consumption. We've talked about this on the show before, but electricity consumption is increasingly becoming a bottleneck, and specifically high baseload requirements of these training runs. Right. The idea that you need a flat, constant, steady amount of power on the grid to accommodate these insane training runs, which play out over a fairly short period of time, too. So have very high kind of time density requirements is anyway pretty important, and it's becoming a strategic imperative. So the development of power infrastructure of new plants, especially nuclear, is starting to be seen as like the key thing.
Next story, Dr. Andrew Ng appointed to Amazon's board of directors. So Andrew Ng, in case you don't know, is a pretty notable figure in the AI world. He was the founding lead of Google's Google Brain project, a professor at Stanford prior to that, also chief scientist and VP at Baidu, and a very prominent researcher as well, has many research papers. Anyway, so he's now appointed to Amazon's board of directors, presumably indicating that Amazon is kind of taking AI quite seriously and getting some of that expertise in.
Yeah, and they quite clearly are kind of framing him up to be this not just technical advisor, but as they put it, help inform the board's perspective on the opportunities and challenges that AI presents and its transformative social and business potential. I think relevant in a context where Andrew Ng is sort of famous for being sort of on the other side of Geoffrey Hinton and Yoshua Bengio and Demis Hassabis, and Anthropic and all that on the idea of AI risk. Like, he's very dismissive historically of the risk of loss of control, even the risk of weaponization to some degree. And so sort of interesting to see him pop up there on the board. Some might raise some concerns about that sort of orientation, especially at Amazon, that has some ability to scale, do very scaled training runs. Obviously, they're a super scaler. So anyway, as they look to catch up in AI, his inclusion there is going to be an interesting factor for sure.
And one last story for the section, and it is that Collaborative Robotics locks up $100 million. So they raised this in their Series B round. So far, they've raised over $140 million, and they are developing these practical collaborative robots or cobots that are designed to work with humans in manufacturing, healthcare, and retail. So again, seems like a lot of investment going into robotic startups and developing more humanoid type robots or robots meant to work alongside humans. I think pretty interesting because, you go back 1 year, 2 years, it was not as much the case. Well, maybe it started last year, I should say.
Yeah, no, you're absolutely right. Now, I have to say, this is a bit embarrassing for me. I had not been tracking collaborative robotics at all. Probably shouldn't be learning about this the first time when they're raising a 9-figure round. So that's good to know. Apparently, their cap table looks pretty damn impressive. They already have Sequoia Capital, Khosla Ventures, the Mayo Clinic, and a bunch of other Lux Capital, a bunch of other companies, VCs that have very, very recognizable names. Like if you're a startup founder, you've heard of these. They're the big ones. Series B is being led by General Catalyst. And so, yeah, really impressive. Total of $140 million raised since 2022. So pretty wild ride for them. I've got to say, this seems like I would suspect over the coming year or two, we are going to see an awful lot more from the robotics side of things, as especially LLMs start to be included as the kind of reasoning scaffold for a lot of these models. And then we start to see more and more bespoke add-ons to that on the software side. But I think the hardware has been making progress too. Like we saw a lot of, I think figure one was sort of the shining star here in terms of having custom actuators and things like that in their setup. So yeah, very, very curious to see who wins out. There's obviously a gigantic market here, so there's more than enough for an awful lot of players to be in the space. But there it is, yeah, collaborative robotics.
And moving on to projects and open source, starting with OpenEQA, embodied question answering in the era of foundation models. This is coming from the FAIR lab at Meta, and it's dealing with embodied question answering, which means that you have a question related to, let's say, navigating an environment and not necessarily just looking at an image. So for example, you could have a question like what color are the blinds, and you would need a robot to presumably explore the environment and be able to answer that question. Another example is, let's say, what food is next to the kitchen sink. And so in this paper, they present the first open vocabulary benchmark dataset for OpenEQA. It has 1,600 high-quality human-generated questions drawn from 180 real-world environments. And they also provide an LLM-powered evaluation protocol. So they present this as a new challenge. They evaluate GPT-4 and others and find that they are still quite behind human-level performance on these tasks. Under benchmarks, GPT-4 can achieve about 55% pass rate versus humans are closer to 90. So yeah, they're presenting this as, I suppose, a new challenge for foundation models and just research in general.
Yeah, I actually thought this was quite interesting, and Meta's been pretty good, especially lately, at identifying some of these like kind of edge cases, right? These benchmarks that are tough for current systems, and coming up with interesting ways to measure them. So they kind of break EQA, right? This like task of understanding an environment well enough to answer questions about it in natural language. They break it down into two families. So they have this thing called episodic memory EQA, or embodied question answering, so EMEQA. This is basically when you have systems that just have to sit back and watch the world rather than being able to explore autonomously, make their own decisions, and like experiment with the world to kind of pull out more information from it. So the sort of like passive observation and then answering questions based on that, that's episodic memory, EMEQA. And then there's active exploration, which, as the name suggests, is, you know, when you have mobile robots that can autonomously explore environments and actually poke around and gather information actively in order to answer questions. It kind of reminds me vaguely of like this distinction between offline learning for RL agents and online learning for RL agents. If you know, you know, but that's kind of the vibe there. In any case, the active EQA one. So again, this one where you have the robot that's able to go out and like do things in the world to help gather information to answer the questions. For that, they set up like these simulations of photorealistic scanned environments, and they spawn an agent in some initial location, and that agent just has to basically do like it's carte blanche, like do any exploratory actions you need to answer a question. So, you know, you ask like, hey, where are the spoons, right? And this thing might go into the environment and like poke around until it figures that out. So it's quite interesting. You then check to see how close the agent's answer is to a human annotated label. And this is a notoriously difficult evaluation challenge because it's so open-ended, right? You get a response from the robot from the agent, I should say, that's like just written in slightly different language from the human annotated label. So how do you actually reconcile those two? And they have essentially an automated way. They use an LLM to score answers based on similarity between the human generated answer and the one that's received from the agent. And they just find through a double-blind study that those kind of tend to correlate well with human preferences. So just qualitatively, okay, that's good. Basically, the LLM is just like scoring responses on a 1 to 5 scale. So pretty simple there. The agent is rated on both the correctness of the answer and the efficiency of its action, which is sort of interesting. The way they do that is by weighing the correctness metric, basically the score that they get from the reviewer, by the number of time steps that the agent's path consisted of, how many actions or how much stuff the agent had to do or how much time had to elapse in order to get that response, which kind of matters because you can imagine the agent sort of doing a very sloppy job of exploring its environment, taking forever to get that answer back, versus a high efficiency agent that would, you know, kind of look in the right place to get your answer quickly and then return it fast. So I thought this was very interesting, a really another fairly characteristically meta paper where it's identifying these tasks, again, that are really sort of challenging for current models to do so you can get a meaningful and informative benchmark out of it.
That's right. And I think the big new bit there is the episodic aspect. Usually, I mean, embodied question answering has been kind of an area of study for a while. But the idea of presenting a video and really it's almost like a video question answering, really, but framed in terms of embodiment. Interestingly, to me, in the abstract, they mention smart glasses specifically. So I guess they could be framing this as, you know, if you have smart glasses and you're walking around and looking around, you know, you might ask your glasses, you know, where are the keys? And it might then have to try and remember it from the video stream. So yeah, a different kind of framing of a problem and a new benchmark for foundation models to tackle. And one more open source story. This one is, I don't know how to pronounce this, IDFX2?
IDFX. It's a French thing.
IDFX2, a powerful 8 billion parameter vision language model for the community. So this one to me is interesting because it is developed and released on Hugging Face, and it's built on top of pre-trained models, Mistral 7B, and released with the Apache 2.0 license. They highlight especially enhanced OCR capabilities and the Apache 2.0 license. So not too much to say on this one, just we have a powerful vision language model released fully open, which there aren't too many of those. And it's interesting to see Hugging Face also releasing models.
No, you're right. I think the benchmarks that they focus on sort of rightly are those multimodal ones. That is the differentiator here. So it's also interesting to see the Mistral or Mixtral line of models continuing to form the basis for more and more sophisticated systems. So I think the era of open source meets multimodality is very much upon us, and that's probably going to be the big next beat.
On to research and advancements, and the first paper is RHO-1, not all tokens are what you need. And that's funny naming, and if you don't know, there's like a trend for naming things like X is all you need, including the famous attention is all you need paper. So this is coming a collaboration between a few universities and Microsoft, and the key idea is selective language modeling, which selectively trains on useful tokens, which aligns with distribution, as opposed to learning to predict every next token in the corpus. So they say that, you know, there are distinct loss patterns for different tokens, and using their approach, they're able to optimize the model accuracy on various benchmarks much faster.
Yeah, I thought this was just like a freaking fascinating paper. One little funny note out the gate, right? So this might be too inside baseball, and if so, I'm very sorry, our poor listeners. So Paul Graham on Twitter at one point wrote, so he's the founder of Y Combinator, sort of famous guy in Silicon Valley. He said, hey, you can often tell that something's been written by a language model because it uses smelly words like delves. Like nobody actually writes the word, we delved into blah, blah, blah in a way that is where it shouldn't better be replaced by another word. There's always a better word than delve. It's just, it has word smell. And Paul Graham, is just really good at writing and writing clearly. And so people sort of like pick that up. In the abstract, this is a direct quote, our initial analysis delves into token level training dynamics of language model. Okay, so I thought that was kind of funny. All right. Joke over. So the basic idea here is imagine the set of all words in the dictionary, or really like all tokens, which can be fractions of words, syllables roughly, but all words in the dictionary, all tokens. Basically, your model at any given time, your language model is trying to predict which of those words, which of those tokens is going to come next in a sequence. And predicting some of those words is going to be harder than others. Some of those words your model will learn fairly quickly, their meaning, and therefore be able to do a good job of predicting when they're the appropriate next word. And then others it won't, right? And so there's this idea that maybe we should worry about detecting when the model has already learned a token well enough that we don't need to invest quite so much in continuing to learn that token. In other words, we shouldn't be training across all our dictionary indiscriminately. Maybe we should be tracking how well we're doing at the different tokens that we're choosing and selectively train more on the tokens that we're struggling with and not train more than is necessary on others. Roughly speaking, that's what we're talking about. In the process, this paper identifies 4 different types, 4 different families of tokens. There's one family where the model struggles with these tokens at the beginning of training. And so this is like, by the way, if you imagine, like pull a model off the shelf, let's grab Llama 2, right? There's some tokens that Llama 2 sucks at right now, like words that it does poorly at predicting. And if we gave Llama 2 some extra training, it would continue to suck at those words, right? So this is the first family. It's like hard at the beginning and it's hard at the end. There are other tokens where it's hard at the beginning and then the model gets better through extra training. And it turns out that about a quarter of tokens fall into that category. There are others where it does really well out the gate because they're probably pretty easy words to begin with, and it continues to be easy to work with those. That's the vast majority, 51% for these models. And weirdly, there are tokens that get harder over the course of training too. About 12% of tokens, the loss actually goes up, the performance goes down on those predictions. Anyway, so one of the key conclusions here is that loss, the training loss, may not actually really be best conceptualized as a single metric. It looks like it. That's how we train our models. But in a way, there's a loss for every token, and the stories that we can tell for each token are different. And if we account for that, we can get a much more efficient training scheme out of our system. And so the actual approach they use is they use a reference model to measure the loss on each token in the dictionary, essentially to assess like how hard are these tokens to learn. And as they train a new model, they're going to check how the loss it attributes to those tokens compares to the original loss that they got on the reference model. And in cases where that difference is really small, you can say, okay, well, that token's basically learned. And stop accounting for it as you continue to train. That's very roughly the idea. It saves on compute. It converges more efficiently. They see a performance boost of 16% relative to other 1 billion parameter models and 10% relative to 7 billion parameter models, which is kind of interesting. So the effect drops with scale, at least as measured here. The last thing I'm going to flag here, this is the first ever 1 billion parameter large language model to exceed 40% on the math benchmark, which actually approaches GPT-4's initial score of 43%. So like, that was its initial score on its first release, by the way. So this is pretty impressive. Not only is this an open source model that's starting to approach the math benchmark performance of GPT-4, but it's a 1 billion parameter model. All the usual caveats apply, of course, when it comes to the risk of data leakage from old benchmarks, blah, blah, blah. But so far, this just seems really impressive. It also matches the SOTA performance of DeepSeek Math 7 billion with only 15 billion tokens of extra training versus the 500 billion DeepSeek Math needed. So a really, really interesting method. Not all tokens are created equal, it turns out. The efficient thing to do is sometimes to mind your tokens.
Yeah, very interesting result. And as you said, the approach is essentially to just train a reference model and then train an LLM with a focus on high score tokens, as they say. The numbers are pretty impressive. Just looking at the paper over right now, they're showing, on average plus 16-ish or plus 10-ish %, depending on the size of the model. So very cool paper. And next up, scaling loss for fine-grained mixture of experts. So this paper essentially asks, how many experts do you need? If you have, let's say, a budget for a number of parameters that you're using, you can, have 4 experts that are each 1 billion parameters, or you can have 8 experts that are each 500 million parameters, and which is the one that you need or want. And of course, if you scale up the number of experts, you also scale up the number of experts you use per pass. So that's essentially the empirical investigation they undertake, and they just go ahead and optimize an equation to find that number changes depending on the scale of the model. So early on, the optimal granularity, as they call it, is 8. And then as you scale up, you want to be going up to 16, 32, 64. They also, in this case, say that mixture of experts are always more efficient than dense transformers, regardless of model size. They actually counteract some previous research, explain that the mixture of experts is always more performant when trained sufficiently. So yeah, very interesting paper. I don't think we need to get into all the numbers and so on, but another kind of very empirical scaling law result that adds to our understanding of how to optimally train, especially very large models.
Yeah, definitely an interesting investigation, data that needed to be out there, right? As more and more models veer towards mixture of experts. Obviously, GPT-4 is suspected to be that, Mixtral, and so on. But this particular paper just results like great as far as they went and all that. I did find this to be a pretty bumpy read, to be honest. It took me a long time to get through it. Some of the issues are like they'll like use some variables before they're fully defined. The figures are poorly labeled. This could just be me, but I thought they're difficult to track. And some of the definitions of key parameters, just the wording of it was somewhat unclear. So it took me a while to figure out what was actually going on here. As you said, it kind of revolves around this granularity parameter, which is like how, roughly speaking, how finely do you want to break down your mixture of experts your set of experts. So in a mixture of experts model, instead of feeding your next token that you're trying to predict, feeding the input all the way like through the whole monolithic model. Instead, what you're going to do is you're going to feed it in. There's going to be a router that's going to point your input to one of a large number or a few of a large number of experts. And those experts are like roughly independent models that run their own computations, and then they get pooled at the end. The sort of outputs of whatever experts were actually activated. Not all experts are activated. In fact, that's the whole point. The idea is to not spend all that computation that would go into propagating things through every expert, but instead you're routing it to specialist models that use fewer parameters each, but are again more specialized, and so can do it hopefully just as good a job with less compute. There's a challenge with increasing the number of experts that you have, and they end up highlighting this later. So they look at like, hey, there's a big advantage, right? As you increase the number of experts, you have more of these specialist models. They get better at doing their respective jobs, and that's great. But you have this problem where you have to account for the compute cost of routing. So if you have a new input that comes in the model and you want to send it out to 6 different experts out of your whatever it is, 64 or something, now you're having to do a pretty complex classification problem, essentially. And that itself consumes more computing power. And so at a certain point, you don't want to fine grain too much because you shade into like burning compute cycles on just choosing the experts, and your advantage starts to diminish. There's also a lot more communications cost from having to send data to so many experts and having to load experts on GPUs and kind of coordinate across all that. So the hardware side of this can become prohibitive when you get too fine-grained. And that was one of their big findings as well. The biggest factor, though, is from the kind of compute cost of routing. This first thing that I talked about of like, we got to send this, figure out which of these 64 different experts we're going to send the next input to. So again, I thought interesting paper in substance. I just it might have just been me. I thought it was a bit of a bumpy ride, but really appreciated the results. And big next step for mixture of experts as they join the class of models that we now have scaling laws for that are a little bit more in the weeds.
Yeah, I read more of an analysis of this paper, so maybe that helped get through it. And as you said, I think interesting to note that in practice, when you try and scale up to hundreds of billions of parameters, there's a lot of like practical aspects involved in just the memory and chip and infrastructure considerations that this would not take into consideration. But still, yeah, interesting results. And moving on to the lightning round, some more interesting results with first the paper Chinchilla Scaling, a replication attempt. So as Jeremy previewed, Chinchilla is a pretty famous paper from a couple of years ago that basically laid out an equation for what is the best way to train your model in terms of what its size and how much data you need to train it and how long to train it for. And this paper looks into one of the ways in which they estimated that equation and essentially says that they were not able to get the same result. Now, they say it's their result is consistent with sort of the empirical findings of how Chinchilla was trained, how other papers have presented their training as. So it essentially is, in a sense, agreeing with the broad idea of what Chinchilla had, while saying that the specific outcome, the specific equation, seems to be off based on the data.
Yeah, this was, I first noticed this because there's a researcher from Epoch AI that I follow on Twitter, now known as X, but always referred to as Twitter, formerly known as X. And he was highlighting this idea like, hey, we finally fixed the big problem with the Chinchilla Scaling Law paper. And I was like, there was a problem with the Chinchilla Scaling Law paper. I thought that paper was all about telling us there was a problem with the OpenAI Scaling Law paper, which it was. But now we have the grand problem of the OpenAI paper. So this was a really badass study, and it is absolutely characteristic of a lot of the research we've seen from Epoch AI. Just like really interesting research team there. They do a lot of stuff on hardware, but in this case on scaling laws. And what they did was they actually reconstructed the data from the original Chinchilla paper by extracting the SVG from the paper figures, parsing out the locations of the points in the plots and their colors, and mapping those coordinates to model sizes and flops and so on, like basically reconstructing the data from the plots. I thought that was so badass. You want to talk about open source? Well, that's how you take a less open source thing, turn it into a more open source thing. You just pull out the SVG. So I thought that was kind of funny. They do look at these scaling laws in the Chinchilla paper. I won't get into the weeds because it actually does get quite detailed, but the original Chinchilla paper had 3 different derivations of scaling laws. The first 2 I remember being conceptually simple and kind of nodding along. And I'll be honest, the third one, when I first read it, I was like, I kind of get where this is going, but it's like hard to. And it turns out that third one is the one they're identifying as having been the one with the issue. So they've used their analysis to conclude, among other things, that the confidence interval that was reported for some of these key parameters was off in that third derivation. They calculated that the DeepMind probably had only about 400 points to use here, whereas to reach the confidence levels that they reported, they would have needed something like 1,000 times that much data to really nail things down that precisely. So something was off, and they started digging, and they just found a different approach. I thought it worth highlighting. Google DeepMind researcher Sebastian Bourgault, I assume he's French with that last name, but anyway, sorry if I'm screwing that up. He tweeted in response, he said, great analysis. Approach 3 is finally in agreement. There was a bit of a discrepancy. He says the loss scale was too low in our paper, resulting in premature termination. Anyway, the details, but this has been obviously noted by Google DeepMind, and they've been nice and classy about it. But characteristically, sort of this like high attention to detail, Epoch AI type of research, tracking, in this case, these scaling laws that are so important.
Next up, not a research paper, but an advancement, and it is that China has developed new light-based chiplets that could power artificial intelligence. So these light-powered chiplets are called Tai Chi. The big deal is that they're light-based, so you could, in theory, have much better scaling. So in tests, this architecture achieved a network scale of what they say like 13.96 million artificial neurons with pretty high energy efficiency. Seems like early kind of investigative work. So far, we've seen some work in this light-based hardware direction, but not anything out in the field. But indicative of people exploring other ways to power AI, for instance, with light.
Yeah, it's pretty impressive proof of concept. I mean, you touched on it, this idea that, typically we see fairly small architectures, like the best people can do with photonic chip architectures is pretty small models. In this case, they are pushing like 14 million artificial, so neurons. Actually need to look and see how many parameter equivalents that is. But one of the key things here really is that efficiency metric, energy efficiency metric. So they hit about 160 trillion operations per watt, or TOPS per watt. which is a lot of operations per watt, right? That's watts as a unit of power. So that's the amount of computation you get per unit of power. If you compare it to the next best result, which was in the same team's paper, came back in 2022, they hit 2.9 tops per watt. So basically, this is like a 50-fold improvement in that critical metric. As we've been talking about, the power consumption of these pieces of hardware being such an important metric now, as power, as energy production becomes a bottleneck on a lot of highly scaled training runs. Just for context, they also highlight a lot of conventional neural processing units, NPUs. These are specialized chips, but also other chips as well, achieve well under 10 tops per watt. So we're already in the a factor of 10 improvement above where the sort of top of the line conventional, say, GPUs would be. And they actually were able to get these networks to do something quite useful. They mentioned, for example, image classification and categorization, some image content generation, just as a proof of concept, right? It's not like these are going to be the amazing sort of DALL-E 3 type images, but certainly it's something that you're starting to see being done with these very unconventional chips. So, always interesting to keep an eye out for this, because these sorts of breakthroughs can, who knows, can potentially change the way that the hardware story unfolds, and therefore who the actors are who are leading in AI hardware as well. This is a Chinese company, right? So if this approach ends up working and scaling, then this is so highly speculative. But down the line, you can imagine a shift in that dimension. So interesting story, new kind of conceptual approach to this sort of computation, and certainly showing positive signs on energy efficiency.
Next up, the paper is OSWorld, benchmarking multimodal agents for open-ended tasks in real computer environments. And that's pretty much the idea. They have a new benchmark of 369 computer tasks involving real web and desktop apps in open domains. It includes, file reading and workflows spanning multiple applications. So one example they have is update the bookkeeping sheet with my recent transaction over the past few days in a provided folder. Another one is, could you help me tweak the code so the snake can actually eat the food, and so on. So there's a lot of apps that can be used here, like VLC, web browsers, file exploration. And as you might expect, this is a pretty challenging benchmark. So the performance of leading LLMs on these tasks is quite low. There's in the 10s or maybe 20s. On average, it doesn't really exceed, let's say, about 12 on a lot of these things. So an interesting benchmark of probably where we would want agents, because a lot of these do involve multiple steps and multiple kind of applications that you would need to use to actually achieve the task.
Yeah, one of the key dimensions that they highlight too is the ability to add new tasks that involve arbitrary applications in open domains as the big differentiator between this benchmark and others. So that's that openness is definitely something that is going to be needed as models, and therefore the agents that are built on top of them, become more and more general purpose. So this is the sort of benchmark that that I think is probably going to be challenging, and then all of a sudden smashed. That's my prediction. It's the sort of thing that human performance, by the way, is in an interesting spot here. It hovers around 70 to 75% across a wide range of different tasks that they have as part of this benchmark. And that leaves a lot of room for measuring superhuman performance too, which I like. A lot of these benchmarks, you design them and it's human performance is already at 95% or something. And this is a quite different case. So so far models not performing too well, right? Relative to that 70 to 75% performance rate. You're looking at typically, I guess, GPT-4V, Claude 3 Opus, doing best here, Gemini Pro V in one case, and performing still in the low tens of percent. So a long ways to go. But the time between defining a new benchmark and that benchmark being smashed is getting pretty short these days.
And moving on to policy and safety, the first story is U.S. Commerce Secretary Gina Raimondo announces expansion of U.S. AI Safety Institute leadership team. The new team members include Paul Cristiano as head of AI safety, Adam Russell as chief vision officer, Mark Campbell as acting chief operating officer and chief staff, and a couple more. So quite a few new appointments here. Paul Cristiano, the new head of AI safety, will design and conduct tests of frontier AI models with a focus on national security concerns and provide guidance on risk mitigations. So yeah, seems like this Safety Institute, which was established within NIST in accordance to the executive order on AI, is expanding and kind of getting going as far as I can tell.
Yeah, it very much does. This is an attempt to sort of catch up to some degree to what's been going on in the UK for some time. The UK's AI Safety Institute was sort of like the first one that was stood up following Rishi Sunak's major push in this direction. The cool thing here is, like, this is a really stacked bench, especially you look at Paul Cristiano, right? This is the former head of alignment at OpenAI. He founded the ARC, the Alignment Research Center, which spun out this thing called METER, which stands for Model Evaluation, and Threat Research. So he's essentially been the guy at OpenAI and elsewhere now who's been working on some of the most advanced alignment techniques. He kind of pioneered some of this like ELK research program, eliciting latent knowledge, and a whole bunch of other things focused on superintelligence and AGI, but also increasingly thinking about just sort of conventional WMD, I guess, along various axes. Obviously, very important in pioneering RLHF, right? We talked about that quite a bit. He was on the sort of seminal application paper of that. So really impressive get for the AI Safety Institute. I will say he was a controversial figure in this choice, right? There was some pushback from folks, I think on X and elsewhere, saying, oh, well, referring to him as sort of a, how would you say, like a safety hawk on the AGI piece. I would disagree with that assessment. I mean, you can argue about whether AGI is likely to happen soon, what the risks are, but he certainly has a rounded pedigree across these various risk classes, and is one of the very rare people who also can cover that in my estimation, that critical loss of control risk. So very impressive pick, and certainly somebody who's up to the task of dealing with the US's very capable counterparts in the UK in a value-added way. So very exciting for both countries and for the global AI safety ecosystem, I think, and a great pick for the Institute.
Yeah, I think the less, let's say, nice term that people use is AI doomer these days, right?
That's right. Yeah,
there's a large probability of doom due to AI, but certainly a very good pick in terms of someone who has worked on alignment and AI safety at OpenAI and now can do that from the US government. Next paper, also from the US, and it is that the NSA has published guidance for strengthening AI system security. The NSA is the National Security Agency, and so they have now released this information sheet called Deploying AI Systems Securely, Best Practices for Deploying Secure and Resilient AI Systems. And I don't think we need to get into it. It provides a lot of, let's say, common sense advice. But I think interesting just to see that they did publish this. And it seems like it's aimed at supporting especially national security system owner and defense industrial-based companies that will be deploying and operating AI systems from external entities.
Yeah, it's also like the cybersecurity framework, the AI cybersecurity framework that was published by the US, I think in collaboration with the Canadian government, the Australian government, a couple others as well. So too is this. This is part of a sort of joint, a joint announcement, joint project, I guess, on building this resiliency in AI systems, especially from the cybersecurity angle. So it's interesting to see continuing work there internationally. It's important because, of course, this is an international problem. Yeah, so the details are definitely worth picking apart if you're into this space. I certainly have found it quite interesting, but I guess somewhat beyond the scope on the just pure AI side. They do look at ways to quickly iterate on identifying known cyber vulnerabilities, right? The ones that we already know about as one of their key pillars here. But they're also interested in focusing more and more on how the AI systems themselves can be undermined and taken advantage of and so on. And so good read if you're into all of that good and important stuff.
On to the lightning round. First up, foundational challenges in assuring alignment and safety of large language models. So this is actually a paper, and they look at foundational challenges in the space. They organize them into 3 categories: scientific understanding of large language models, development and deployment methods, and socio-technical challenges. So a very, very long paper, like hundreds of pages, not hundreds of pages, but a lot. And so just to give some examples, in the scientific understanding of language models, they cite in-context learning, estimation of capabilities, effects of scale on capabilities, agentic LLMs, stuff like that. In development and deployment, they say pre-training produces misaligned model, LLM evaluations are confounded and biased, and so on and so on. There's so much in this really big paper. They say they pose 200 plus concrete research questions. And there's many collaborators in this one, 23 different people cited, with Usman Anwar from the University of Cambridge being one of the first authors.
Yeah, it's funny. I was just looking at the author names again, and it's like, wow, there are a lot of big names here. You've got, of course, Yoshua Bengio on there, Jacob Forrester, who's done a lot of work on, I think, what do you call it? The environment generation, procedural generation of gaming environments, if I recall. And David Scott Kruger. It's a big old Marcus Anderlung, formerly at the GovAI. So really kind of an attempt to, if not, as they put it, if not be comprehensive, at least be if not be exhaustive, at least be comprehensive. Not 100% sure what the difference between those is, but boy, is this I would call it like pretty complete. There's a lot of stuff. So they look in particular 3 categories of challenges. This issue of developing a scientific understanding of large language models. The real differentiator here, by the way, is the fact that we're looking at large language models, right? Like that's the focus specifically of this work. There are other papers that do these sorts of high level looks at the safety landscape. Famously, Concrete Problems in AI Safety, which Dario Amodei was a co-author on back in the day, was this, like, I think one of the first attempts I ever saw of this comprehensive sort of treatment. But this is a specific treatment to LLMs. It's also updated. So anyway, useful there. But they look at at scientific understanding and trying to interpret and get a better sort of scientific theory of how large language models function to help inform development and deployment decisions, which really, really important. Obviously, something that, we highlighted in our action plan that we've been focused on. It's like this need to be able to predict what is actually going to happen at the next level of scale and how are these systems going to behave, what capabilities will they have. They separately look at development and deployment methods. This may be more on the engineering side, looking at challenges, for example, that come from fine tuning as a means of achieving alignment. So you may be fine tuning your model on human feedback, but what you're really doing is creating a model that's trying to get an upvote from a human, which is not the same thing as being helpful and honest and truthful and all those good things. And it also discusses what it refers to as the ongoing evaluation crisis, which I think I'd never seen that phrase before. I think that's actually a really good one, and one that I will be using from here on out. It is the case that we don't know how to evaluate these models. There are indications they can actually detect when they're being tested and adjust their behavior accordingly, which undermines the entire conceptual foundation of every evaluation technique currently known to exist. That is not an exaggeration. So how do we run evaluations for models for dangerous capabilities when like their behavior is subject to change based on their own assessment that they're being evaluated. It's a problem that a lot of people think is going to be getting worse soon as models get more situationally aware. The last one is socio-technical challenges. So they look at basically like, think of not just the model, but think of the model embedded in a team, which is embedded in a company, which is embedded in a, in a country, in a city, on a planet, all that good stuff. So a lot to dig into here. It's meant to be a primer if you're interested in doing AI safety research to try to like guide your exploration of potential research trajectories and research projects.
Next story, former OpenAI board member calls for audits of top AI companies. So this is Helen Toner, the famously former OpenAI board member involved in the big drama over OpenAI when Sam Altman was briefly not the CEO of OpenAI. And so this is just covering her TED Talk in which she talked about various things, including the idea of AI audits that would scrutinize the work of these big companies. She also recommended that tech companies establish incident reporting mechanisms. And so I suppose interesting to note, just in the sense that, OpenAI probably may not want to be audited, or maybe if they wouldn't mind, it's hard to say, but this coming from the former board member is somewhat significant.
This is not inconsistent with somebody who is concerned about OpenAI's willingness to do the right thing when it comes to evaluations. It's hard to know. Opinions vary within the company, certainly, and there are people who think that they do just fine. But here is Helen, somebody who's had access to the company to some degree from the inside as a board member, but obviously not information. All information is going to be shared with them. And yeah, she's saying as part of a TED Talk that leading AI companies should be required, to share some information. In particular, this is interesting, information about what they're building, what their systems can do, and how they're managing risks. What they're building is an interesting inclusion here, right? This isn't just like, hey, we're announcing a model that we have built. It's what models are you currently building? That's interesting, not just in and of itself, but also in the context where some people have certainly reported, in particular red teamers have reported that they went to OpenAI's board to share information with them about what some of their most advanced models could do, and that the board was not aware of these capabilities, which in some cases were surprising and concerning. So in that sense, this is a level of visibility even the board isn't having. I've heard of folks internal to OpenAI not having a clue still why Sam Altman was let go from the board and as CEO initially. In a context where this is a company that explicitly sees itself as making transformative choices on behalf of human civilization, if you will, to the extent they think they're telling a true story there, one that's likely to be true, it seems like we all have a dog in this fight. We should probably know what's going on under the hood there better than we currently do. So this seems to be, Helen Toner coming out and saying something like that. She called for AI auditors to be allowed to scrutinize their work so that the companies aren't just grading their own homework. To OpenAI's credit, they brought in the Alignment Research Center, as it was then called, to do an eval on GPT-4. They did not allow it to have access to the latest version of GPT-4, though, which actually was the first to go live, nor, I believe, were they able to fine-tune the model. I'm trying to remember if that was the case, but I believe that may have been the case. So there are definitely some issues about access and up-to-dateness when it comes to these external third-party evals that, frankly, I think we're at the stage now where we need frontier labs to be more open about this stuff. Not a good thing that we have former board members calling for this kind of transparency when they have an indication of what has been happening under the hood there.
And one last story in this section. Society of Authors survey reveals a third of translators and quarter of illustrators losing work to AI. So yeah, there's a lot of numbers in the survey, which is from January 2024. It says that 37% of translators and 26% of illustrators have lost work due to generative AI. There are also some numbers here saying that 22% of respondents have used generative AI in their work. A lot of them just for brainstorming, some of them due to being asked or commissioned to, there was a request for that to be done. Most, a huge majority, 86%, expressed concern about their style, voice, or likeness being mimicked or reproduced with generative AI output, and almost all, 95%, called for government to introduce safeguards and regulation to ensure compliance with measures of consent, compensation, and transparency. So I suppose not necessarily super surprising numbers here, but worth noting that this is reflecting a reality that there is a very significant impact already being had by AI on many people, particularly in these careers.
Yeah, it's funny. I'm old enough to remember when the conversation was about how AI would not replace, but it would augment human beings across the board. And this isn't to say that's not entirely inconsistent with this picture, right? Because at least the way this is framed is we have a quarter of illustrators and over 2/3 of writers have already lost work due to generative AI. It doesn't mean they've lost all work. It just means they have lost some work, or at least that's my interpretation of this. But still, I mean, I think by now it's pretty clear where this is going. It is, it's moving fast enough that if Devon ever ends up actually working, which I suspect it's likely to sooner rather than later, coders are going to be out of a job like entirely. Junior coders are going to find it a lot harder to get work, and we're already seeing that play out in other fields. So I think the level of social disruption implied by these numbers, if this is the worst AI systems are ever going to be, right? We talk about that a lot on the show, but just project current trends forward. Would you have bet on this level of automation 4 years ago? And if not, what does that imply about the next 4 years and where we're going to have to be from the standpoint of dealing with the potential social disruption that comes from this? This is pretty significant stuff, right? I mean, this is like big chunks of an entire industry are seeing big chunks of their livelihood taken away. It's not a thing to take too lightly. And anyway, a lot of change in our future for sure.
For sure. And just one last story in synthetic media and art. And it is that Medium bans AI-generated content from its paid partner program. So specifically, stories entirely generated using AI will be removed from paywalls and actually could result in users being expelled from Medium's monetization program. And Medium, if you don't know, is kind of like a YouTube for writing. You publish various writings there. You can put it behind a paywall. So yes, the company does let you use AI to assist in writing, but with this new policy, which is taking effect on May 1st, you would not be allowed to post fully AI-generated stories. And apparently, you also must properly label and source AI-generated images. So I think it's kind of notable to have this policy coming from a major platform, right? I'm sure like in a year, it'll be interesting to see if YouTube will say you're not allowed to post or monetize fully generated videos, right? Right now, That's the case with writing. And so, that's, I think, is the world now where we have covered a lot of spam from various places being created by AI. And I'm sure people are trying to do this on Medium as well, just posting fully generated stuff as a cheap, quick way to get some cash. Hopefully Medium can figure out how to restrict it and not kind of have the platform be polluted in that way.
Yeah, and they're definitely going to be the most incentivized among all the kind of the main publishers to do something like this, right? Because if you think about the incentives that apply to like any other, don't need to name them, but any other kind of publishing company, what Medium has going for it is that basically it has the equivalent of Uber drivers submitting stories to them, right? So like everything there is not on contract, or it doesn't rely on employees to do their writing for them. What they do is they have a gig economy underlying them and supporting them with basically free content, and then they do rev share with those content creators. Whereas you look at other companies, publishers that actually pay their writers a salary. The question then becomes like, okay, well, can I get rid of those writers? And Medium doesn't necessarily sort of suffer that economic penalty in the same way. So yeah, definitely they're going to be the canary in the coal mine, the vanguard, whatever the word is for the strategy. And we'll see if it continues to apply, a year from now, if they actually end up sticking to this, or if it just becomes in practice impossible to enforce or what have you. So yeah, this will be a good test.
And with that, we are done. Thank you so much for listening to this latest episode of Last Week in AI. Once again, you can find the newsletter at lastweekin.ai, and you can find emails to reach out to us and give your feedback or just comments in the episode notes. As always, we do appreciate your views. We appreciate you sharing the podcast. And more than anything, we appreciate you listening. So please do keep tuning in.